Hello everyone. Welcome back to another episode of Coding with Culp. It's been quite a while since I've been putting out any type of regular content. My goal in 2025, my New Year's resolution, is to try and grow the channel and to do or average one video every 2 to 3 weeks. That'd be an average, so there might be a time frame where I put out more than a video every 2 to 3 weeks, and there could be a break where I don't put out a video, if I don't get it on time in every 2 to 3 weeks. But I'm going to try to grow the channel. Main content is going to be programming related. I know I do a lot of stuff with Python and Pygame, but I plan to branch out into C, C++, Rust, and other programming languages. In addition, I plan to expand a lot of the retro computing content that I have. In fact, I got quite a few videos planned for that. I got a full-sized Altair 8800 replica that I'm going to be putting together. I have an Apple I replica that we're going to be putting together, and quite a few other things. So anyways, I'm going to try to keep up better with the channel. Now, today's video is all about a Christmas-themed Space Invaders game that I put together. About, 3, maybe 4 days before Christmas vacation began for me because I'm a teacher. So our last day of school was the 20th. And so maybe about the 21st, 22nd, I got an idea to do a Christmas-themed game. And the reason I got that idea is back when I was a kid with my Commodore 64, you often downloaded or found these cool little holiday themed programs and games. So I wanted to do one of those. And so I came up with the idea of Santa Invaders, which is a Christmas themed Space Invaders. And so I started work on it. And I've been busy Christmas and everything. I did not get it done in time. Didn't get it done anywhere close to in time for Christmas. And so here we are about, 4 days after Christmas. What's today? Oh, we're like 5 days after Christmas. And I'm doing the video for the actual game. Now, I did do a video earlier, in fact, last night, and that video came out to be right at 2 hours long. Nobody wants to sit and listen to somebody talk about code for 2 hours. So I'm going to redo the video, and I'm going to try to make it much shorter, which, by the way, I would really appreciate it if you like the video, subscribe, and comment down below. I'm also going to give you 2 ways to get the code or to get the game. Way number 1 is going to be going to GitHub and downloading it from there. In fact, I'll show you how to do that right now. So if you go to GitHub to the link, it's going to look like, let me go to here. All right, it's going to look like this, the link that you get. And all you have to do is come right over here to code. Click that green button and click download zip. That's going to download you a zip file. All you have to do is unzip it, and all the code and graphics assets and everything else will be in that folder. And then all you have to do is run the SantaInvaders.py, which you're going to have Pygame installed. You're going to have Python installed. And as far as Pygame, you got to have a minimum version of, I believe, 2.6. Let me check that out, or 2.4. Let me check that out real quick. Python 3. All right, so let me import Pygame. And yeah, Pygame 2.4. I have run this on my Linux machine, which is what I'm recording this on. I've run it on my Windows machine, and I've also ran it on my Raspberry Pi 5, and it ran just fine on all 3 of those, as long as I made sure I had the most up-to-date Python and Pygame installed. If you have any issues with it not recognizing functions, it's more than likely you don't have a good enough version or the latest Pygame or Python. So make sure you install those. And the other thing I'm going to do is I'm going to give a link to it to itch.io, and that itch.io link will also have a Windows executable, so you don't actually have to have the Python files or anything like that. You can just run it on Windows. If I get time, I'll try to make a Macintosh, a Mac executable on my Mac, and a Linux executable. But for now, the itch.io link will have the Windows executable so that you can just run it. And so let's take a look at the game real quick. If you've played Space Invaders, you've played Sand Invaders. So here we go. Let me correct that real quick. All right. So here's our title screen. It says press space to begin. And so here we go. So I've got a level system in. This is level 1. I am having a little issue with the sound. I converted the sound from MP3s to WAV files, and some of the music is a little bit scratchy. And so I might do a reconversion. In fact, there it is. You can hear it right now, I think. So if the invaders get too low, like they just did, your shields disappear, which is shields of fireplaces. And one of the things I worked really hard on, one of the things that I really wanted, and it's something that was a big goal of mine, was I wanted the fireplaces to erode over time, just like in real Space Invaders. And that took me a little while to figure out how to do, but I'm going to show you how I did it. Maybe you've got a better idea for how to do it, but it was something that took me quite a while. Whoops. Now, if the invaders, and I'll show you, if the invaders get a bit too low, the game will be over. And you only have 1 life. Oh, let's get Santa. Oh! Santa's bag that he throws at you is guided, so it's going to try to, find you. It's going to guide itself towards you. There is a high score system, as you can see right here. You don't get to enter your name. All it does is it reads your username that you're logged in as on whatever system you're logged in as. So let's go ahead and restart again. So we're back at the title screen. The Santa that you see along the top, I think he comes out. He has a chance to come out every 11 seconds. So you can see the fireplaces being eroded as they get hit. And if a fireplace takes too many hits, it deactivates. Now let me try to actually make it past this level. This level is actually pretty easy. The invaders are going slow. They don't fire that often. Okay, there's Santa again. And he has his own sound when he comes out. Okay. Let's try to hit Santa. I think we're going to get him. Yep. And on level 1, he's worth 300 points. Alright, I want to make it to level 2. And then we'll stop playing. So each level, I got 5 levels, has a different invader graphic. I really wanted to have like different effects and different things for each level, but I just didn't have time. Maybe that's something that you can do. So the controls are left and right will move you, spacebar or the up arrow key shoots. And one thing to note is that you can only ever have one of your tree toppers, the stars, in the air, or missile, or whatever you want to call it, at a time. And so, if you hit the spacebar, oh, I'm about to, okay, there we go. If the invaders get too low, in fact, I'll just show you that right here. If the invaders get too low, it's game over. And as you hit them, they get slowly faster. There we go. So the invaders got too low, so the game was over. They're below the level of the top of the treetop. So that's the game. So let's go ahead and let's dive into the code. And I think the best thing to do is to essentially start with the startup code, and then we'll take a look at, or we're going to take a look at first our data structures, and then we'll take a look at startup code. And instead of going the whole thing line by line, I think I'm just going to hit some of the highlights of the code. And I've got it commented okay. I might comment it more, but it shouldn't be too difficult to understand. So let's get started. Okay, let's start our exploration of the code for Space Invaders with the data structures that control most of the game. And I probably, if I had this to do back over again, I might have gone back and wrote classes. But I didn't at first because the game was going to be super simple, which it is pretty simple right now. But I didn't want to take the time to write classes. So I basically put everything into a dictionary. Anyways, the game has very variable resolutions. It can support a variety of different resolutions. When I first wrote the game, it was written at this 2048 by 1536 screen resolution, which fits on a 4K display. But not everybody has that high of a resolution. And so I wanted people that didn't have a 4K display, which I know that 2048 isn't by 1536 isn't 4K, but it fits on a 4K display. And so I wanted more people to be able to run the game if they had a lower resolution setting on their monitor. And so this data structure right here just holds the X resolution, Y resolution, and a scale factor at that resolution for each one of those resolutions. And then we're going to initialize Pygame. We're going to read the user's current resolution, what the screen width and screen height is. And I give a little bit of buffer on the Y. Modern monitors are much longer than they are tall. And the game is set to run in 4:3 ratio, a 4:3 ratio. Old school monitors, especially for old school arcade games, had a 4:3 ratio, whereas modern monitors generally, most, not all, are 16:9. And so they're much longer than they are tall. And so I noticed on some of the screen resolutions that it could be so tall that it just barely fit in that height. And so this gives it a little bit of a buffer zone when it checks the resolution. Then all this does is it checks the width and height of the user screen versus the width and height of each resolution. Once it finds a resolution that it can fit within, it sets this variable called max resolution to the width, height, and the scale factor. And what that scale factor is we're going to multiply all of our graphics, all of our movements and stuff like that by that scale factor, so that it fits on the user's screen and the speed seems the same. So the scale factor of 1 is this 2048 by 1536, because that's what I first started programming the game in. And then everything else will be multiplied by a scale factor that's smaller so that it will fit on the screen. So let me show you what I mean. I'm going to override that max resolution, and so I'm going to uncomment this out, and we're going to set it to the smallest resolution that it supports, which is 1024 by 768, which is a scale factor of 0.5. And so when I run it, you can see it's a much smaller screen, and it all fits in there. And runs at about the same speed. One other thing I forgot, if you press F, it gives you the current frame rate. And S is a cheat code that automatically clears the screen. So if you want to see what each level is, you can press S. So there we go. And then the very last level, level 5, is Evil Snowmen. You can see how fast that was. Then after that, after level 5, it just randomly selects a enemy graphic. All right. This right here, most of it's just boilerplate Pygame code. We're going to set our screen width and screen height and scale factor based upon that resolution. I define two constants, left and right, and what we're going to use those for is when the invaders are moving left and right, we multiply their speed by either left or right, which is -1 or 1. So if they're going left, we multiply their speed by this left constant, and it causes their movements to go to the left, etc. Once again, some boilerplate Pygame code. And then I got a bunch of game constants for the game state. So the way I control what's happening in the game is by setting these game states. So if I set the game state variable to game state title, it's going to show the title screen. When it's running, game state is set to game state running, etc. Explosion frame duration is another constant that you can change and fiddle with. It's how long each frame of the explosion animation is on screen. Now, the level system is really quite simple. I've got this big list. It's a list of dictionaries. And so for each entry into that list, we have a dictionary. And it basically configures the level. The image file for that dictionary or for that level is just that. It's the image file for the invaders. The invader graphic, the invader speed that they travel during that level. And you'll notice that each level, they get a little bit faster until they're on level 5. They're at 8. I have never gotten past level 4. So maybe one of you out there can get past level 4. The Santa Sleigh points, how much hitting Santa Sleigh at the top is worth, how much each invader is worth. Each invader, or the invaders, have a chance every single frame of taking a shot. And so this is a 1% chance every frame that the invader or a invader will take a shot. Guided bag, that's Santa's guided bag that he shoots down at you. How many points is it worth? And then the present speed. That's when their presents that they shoot, that's kind of their missile or bombs, how fast they travel down the screen. And the faster they travel, the harder they are to avoid, etc. And so if you wanted to put in a new level, all you had to do was, all you have to do is copy this, Control C, and put a comma, and then paste it into place. And then change, come up with your own graphic. I think the graphics are about 100 by 100 pixels for each invader, and configure this stuff right here. All right. Let me Control Z a bunch. All right. Now, this right here, the game data. The game data kind of collects all those variables together that I use to keep track of the game state. And I've got this default game data. And it's a dictionary, which, by the way, dictionaries are a whole lot faster when you're looking stuff up than a list is, depending upon what you're doing. Okay, if you have to search through that list to find what you need, a dictionary in Python is something like 6 to 7 times faster. And with Python and Pygame, you want as much speed as you can possibly get. I haven't had any speed issues with this game. In fact, on my Linux machine, which is just a little tiny little box, one of those mini computers called a Nuke, Nuke. Anyways, it's a pretty small computer. This thing will run at about 1,000 frames per second if you turn off the frame rate cap on it. So got no speed issues. Anyways, the game state is just that. It keeps track of what game state we are in. And we're going to start out with a default of game state running. Actually, I could probably change that to game state title. But anyways, the player score, their high score, the current level they're on, notice it's at -1. And that's because one of the first things we're going to do when we start up is we're going to call the next level function, start next level. And the first thing start next level does is it increments the current level. So that's going to be 0. Now, we're going 0-based counting here. So level 0 is really level 1 because over here, this right here in level data, this is index 0 into that list, okay? And so we're going to start out with -1, and the first level is going to be level 0. Although when we display it, we're going to add 1 to it when we display it. The game sound state I don't actually use. I was going to have a configuration screen where you could turn sound on and off and a few other things. But anyways, fireplaces, those are their shields. Are they active? If they're not active, they're not going to be displayed on the screen. Sleigh time, Santa's sleigh up at the top has a something like a 1 or 2% chance of appearing every frame, every 11 seconds. So once he goes off the screen, a timer starts, and he won't appear for a minimum of 11 seconds. Santa's sleigh active, basically, is his sleigh at the top active or not? Invaders deer, which direction are they currently traveling? Are they going left or right? DIR is just short for direction. The star is the player's missile. The star at the top of the Christmas tree. Is it active and on screen? The speed, if you want to make the game easier, make this faster, make it larger. The star will travel up the screen faster. The guided bag, that's Santa's missile that he shoots at the top. He throws his toy bag down at you. And that's the one that guides itself towards you. And that's the guided bag speed. Once again, make the game harder by increasing this. And in fact, that might be something that we actually put in the level data. So that maybe as time goes by and you go to more and more levels or higher level, it gets harder. Show FPS, that is, do we want to show the frames per second in the lower left? And once again, the key for that when you're playing is F. Invader speed add. So every time you kill an invader, it adds 0.1 to this invader speed add. And the invader speed is calculated every frame as their invader speed, which is set by the level, plus whatever the invader speed add is. For example, let's say you've killed 10 invaders so far. Well, 0.1 times 10, because we're adding 0.1 every time, is 1. So that means the invaders in level 5, after you kill 10 invaders, will be traveling at a speed of 9 across the screen. And once again, you can make this game a little bit harder by adjusting that speed add variable that I'll show you, or constant that I'll show you later. And then the player speed, how fast do they go. Now, we're not going to operate on the default game data. That's kind of like our saved. This is our default state. We're going to make a copy of that dictionary, okay? And we're going to call it game data. And that's what we're going to operate on. And we're going to set the initial game data to game state title. Because we want to see the title screen. All right. Sounds and music is pretty much straightforward. Pygame stuff, I'm not going to go over most of it. Other than this right here. Inside of the media folder, there's a music folder. And it's full of WAV files. If you want to add your own music, just put WAV files in there. Convert MP3s to WAV files. And what this song list glob.glob does, and you got to import the glob package. All it does is it grabs every single file, including its path. It grabs everything that ends in .wav. And so we have a list of songs. And then we're going to set current song, the current song we're playing, equal to none. Because what's going to happen is we've got a function, I'll show it to you in just a minute, that chooses a random song for us to play when we start each level. We're going to set the music volume to 0.5. And I've had difficulty kind of coming up with, I don't know, a good music level. Anyways. And then we're going to set our sound channels to 64 channels. So we can play up to 64 sounds at one time. This right here sets up an end music event for Pygame. And we're going to set this constant end music event equal to pygame.user event plus 0. And I believe we can actually get rid of the plus 0. And then we're going to say pygame.mixer.setMusic end event is equal to this end music event. And so what will happen is when music stops playing, when a music file stops playing, this Pygame event gets triggered. And we're going to check for that. And if that event gets triggered, and I'll show you where we do that later, if that event gets triggered, we're going to call a function called playNextSong. That's going to then choose another random song. And this just positions the window, our big game window, in the on the user's desktop or on their screen. Font setup is pretty straightforward if you know Pygame. Notice right here's where I use that scale factor. What I'm going to do here is I have a default font size, which is 100. But that's going to be too big for smaller resolutions, smaller game resolutions. So I just multiply it by that scale factor to make it smaller. We're going to load our title screen right here, and we're going to scale it, PyGameTransform.scale, to our screen width and screen height. Now let's talk about images. So everything from line 1025 down to about 1100 is all about loading up images. And what I do is pretty standard Pygame once again. So what I do is I have a function that I made called load image. And what load image does is it takes a file, an image file, which I use PNGs, and a scale factor in the X and a scale factor in the Y direction. And that's our scale factor that we calculated up when we set resolution. So let's go take a look at that load image and let's see what it does. So all load image does is it says image equals Pygame image.load file name.convert alpha. Make sure you're using convert alpha so that the images you bring in are in the best format to be displayed on the screen, the fastest. So we're going to create an image by loading in this Pygame image.load, and then we're going to call another function, scale image by, which is right up here. And it takes an image file, and once again, a scale factor. And what it does, so it's going to hop up to here, and it's going to take that image we just created, and it's going to scale it. Okay, it's going to say image.getHeight times scale factor y, and it's going to calculate a new width for the image for image.getWidth.scale factor. And then it's going to use the Pygame transform.scale function. And it's going to take the image with our new width and our new height. So what Pygame.transform.scale, all it does is it takes an image, a Pygame image, and it scales it to a new width and a new height. There's actually a newer function called scale by in Pygame, but it worked on my Linux machine, but I could not install. I want to say on my Raspberry Pi, I could not install the latest version of Pygame. I was having some difficulty. I'll have to work on that later. And so I finally just wrote these two functions that essentially loads an image and then scales it and then returns that scaled image. What was that on? 1025? Yeah. All right. And so then we're going to keep track of the player width, player height, player rectangle. This is all pretty standard Pygame stuff right here. Star missile setup, it does the same stuff. Also, because we're going to be doing mask-based collision, which I'm going to talk about here in just a bit, we want to keep track of the star mask. Okay. We're going to load Santa's guided missile. The invaders, what they do, so the loading for the invaders is pretty much the same. We're going to load its image, but then we're going to do this make invaders array. And so let's take a look at that function, make invaders array. So what I did was, because the invaders are on screen in 5 rows and 11 columns, I just made an invaders array, or a list of dictionaries, a list of lists that each contain a dictionary. And that dictionary just keeps track for each one of the invaders, because this array is, once again, 5 rows by 11 columns. I could have wrote this out a little bit more using for loops, but this is a list comprehension. So if you don't understand what that's doing, it's basically collapsing a for loop, two embedded for loops into one. And it's going to create a structure that is a list of lists. And essentially, each list inside the list of lists, we're going to have 5 lists inside there that each have 11 dictionaries in them. I hope that makes sense. Anyways, each dictionary is going to keep track, is the invader currently active. It's going to keep track of their rectangle, their current rectangle, whether they're exploding or not, the explosion frame that they're on, if they are exploding, and then the explode time just keeps track of what was the last frame switch time. Remember that constant we had up near the top? We're going to switch frames. Okay, we're going to advance the explosion frame when that time has passed. All right, let's go back. Where were we? So that's the invader setup. And I keep track of the invader, the upper left corner of where that array should be drawn. Okay, so the upper left corner is always going to be 0 to start. And this right here, it's always going to start 120 pixels down the screen. That's where the invaders start, or we're going to start drawing them, multiplied by the scale factor. So, for example, the scale factor was 0.5. They would start being drawn 60 pixels down. Santa Sleigh's pretty standard. Snowflakes, all we're going to do is, once again, a list of dictionaries. And each dictionary entry in that list is going to be a snowflake that keeps track of the X, Y, the size, and the speed of that particular snowflake. And then to draw it, we just loop through it. Fireplaces, about the same for loading. And we also have this make fireplaces array. So let's take a look at that. This is where things get complicated. I mean, not super complicated, but it took me in my small mind a little while to work this out. The fireplaces, once again, when we draw them, we have 4 fireplaces. We want them spaced out an even number of spaces across. 772. What did I do? What? Okay, there we go. All right, so you see the fireplaces are spread out fairly evenly across the bottom of the screen, with an equal amount of space on the ends and in between. So let's go back to make fireplaces array now that I corrected whatever happened there. So what we're going to do is we're going to loop through the array 4 times, or loop through 4 times, because we have 4 fireplaces, right? And we're going to calculate the gap width. X equals gap width. So let's come over to here, back down to here. Let's go back to the fireplaces. All right. What I did was the total gap space. That means the total amount of empty space. If all the fireplaces were drawn, back to back, is going to be the screen width minus just 4 times the fireplace width. So that's going to tell us how much empty space total we're going to have. And so then for the gap width, because we're going to have 5 gaps, okay, 1 on each end and then in between each fireplace. So it's going to be 5 gaps. And so the total gap space is just going to be, or the gap width, is going to be the total gap space divided by 5. And if I really wanted to, I could take this out instead of making it a global variable, and I can just put it in the make fireplaces array and do that calculation here. There we go. Should still work. And it does. Okay. So then what we do to make our little fireplaces array is we're going to loop through 4 times, because we have 4 fireplaces. And the X, where the fireplace is going to be drawn, that particular fireplace, is going to be the gap width times I plus 1. Okay. Essentially fireplace number 1, which is going to be element 0, we're going to multiply it by 1. So it's going to be the gap width plus the fireplace width, once again multiplied by I, where we are in the loop. So let's take a look at fireplace 1. Let's say fireplace 1 that we're going to draw. Let's say each fireplace has a width of 100. We're going to take our gap width, and once again, let's say the gap width was 100. Gap width of 100 times I plus 1. I is going to be 0 the first time through the loop. So gap width times 1 is, in fact, 100 plus fireplace width times I. Once again, because I is 0 the first time through the loop, it's going to be 0. So we're going to get 100. Our first fireplace would, its X would be 100 pixels over. And then for each fireplace, we're going to set whether it's active or not, its X and Y, a number of hits it's taken. Remember, each fireplace can take a certain number of hits. We're going to set a rectangle for it, a surface, and a mask. We got to keep track of these two because we're going to erode the fireplaces over time. All right, let's head back to here. All right, the rest of it's pretty simple setup for the presents. Explosions, we just have a list of graphics images for each frame. And then we go into our main game loop, which is all this right here. And so all this right here, we're just going to check for some events. Pygame.quit. If so, we're going to set the game state to quit. We're going to look for key down. If they press the escape, we're going to set the game state to quit. Event.key.p. If they press the P key, we're going to set the game state to paused. If they press the F key, we're going to flip-flop, or we're going to toggle the game data show FPS. And then if we get the end of music event, we're going to fire off that play next song function. And then right here is where we respond to the game state changes. If we're in game state over, we're going to hit the game over function. If we're in game state pause, we're going to display the pause screen, etc. And then right here is our main event loop where we're going to get input, update, detect collisions, draw the scene, update the display, check to see if the level's ended, and then wait to make sure we don't go over 60 frames per second. So now what I'm going to do is I'm just going to hit some highlights of the more complicated functions. All right, looks like the video is already close to 37 minutes long, and I want to keep it below an hour. I'd really like to keep it below 30 minutes, but I tell you what, let's just go through the functions, starting maybe from the top, and I will hit some of the highlights. So play next song is pretty self-explanatory. All it does is it grabs a random song, and then while the random song it grabbed was the same as the current song that was just playing, we're going to keep choosing a song until we get a different song. Play sound, pretty self-explanatory. We got 64 channels to deal with, so we're going to play the sound that was passed to it, grabbing a channel. If the channel is not none, we're going to go ahead and set its volume to 1. Scale image by, we've already done those. Display pause screen, pretty self-explanatory. We're going to make some text and then blend it to the screen. Most of the text I do with a drop shadow. So what we do is we have a pause text and then a pause text shadow and instruction text. And instruction text shadow, excuse me. And we do them in different colors, red and green. And then when we display them, which is right here, okay, I display them, you can see +5 here and +5 here for the pause shadow and pause text. So they're offset just a little bit by 5 pixels in the X and 5 pixels in the Y direction. Gives kind of a cool drop shadow effect. Display title screen, all it does, we're going to stop all the music. We're going to wait 1 second at the top of it. It debounces the space bar. If you press the space bar at the end of the game and you keep it held down too long, or too long could be 1/10 of a second. Sometimes once it's switched to the title screen, it will immediately then start the game. So this gives a little bit of a pause. We're going to stop all music and sound. And then all we do, once again, is we just wait. As long as we're still in the game state title, we're going to just keep going. And if they press the X to end the program, we're going to set it to game state quit. Or if they do press the K key, or excuse me, not K key, the escape key, we're going to set game state quit. Otherwise, if they press the space bar, we're going to set the game state to game state running, and we're going to reset the game, which is the next function, which is super, super simple. Notice reset game takes a parameter. It says load next level. It's either true or false. If it's true, we're going to go ahead and load the next level. So we're going to call this function start next level. All reset game does is it resets our game data variable by, once again, copying that default game data dictionary. High scores management, pretty simple to understand. There's 4 functions. Yeah. Load high scores does just what it says. It loads up, opens the highscores.txt file, loads the high scores into a list, and formats it. Save high score files, once again, just takes a list of high scores. And by the way, the high scores are name followed by the high score that they made, their score. This writes out a new high score file. Update high scores. It just takes a player name, their score, and the high scores list. And all it does is it inserts them into that high scores list, which is 10 entries. So it's going to insert them into that list, making it 11. It then sorts the list, but only keeps the top 10. Okay? Only keeps the top 10. And display high scores, pretty self-explanatory. It's going to iterate through that high score list. But one thing is, if the name equals the player name, okay, and the score equals the player score, we're going to put that in green, showing that they made a new high score. All right, game over screen, pretty self-explanatory. Once again, we're going to stop playing sounds. And we're going to get the current user. That's what getPass.getUser does. It's going to get their username that they're logged in as, no matter what system they're logged in at, whether it's Windows, Linux, or Raspberry Pi, which is running Linux. It's going to get the new high scores, and then update the high score list. And the first thing we do is we're going to have basically a game over text for a bit. It's going to stop the game, write that game over. And then after a 4-second pause, it's going to proceed to the standard game over screen, which is going to show all of the high scores. And then once again, just a standard thing. We're waiting. I can probably combine all this into some kind of a function. But anyways, we're going to wait for user input. And then if they quit the game, we're going to quit. If they press the space bar, I can get rid of that. It's old. If they press the space bar, we're going to set the game event to game state title. We're going to wait 500 milliseconds, half a second, just to once again debounce that space key. All right, draw scene. Here we go. Draw scene is one of the more complicated functions, or one of the longer ones. We're going to fill the background with that kind of dark color. It's not black. I like it better than pure black. We're going to iterate through our snowflake list, drawing our snowflakes. Once again, it's a list of dictionaries. We're going to get our XY size and draw the circle on screen. We're going to draw the player image, pretty self-explanatory. We're only going to draw the star if it's active. We're only going to draw Santa's sleigh if it's active. We're only going to draw the guided bag if it's active. Right here, we're going to draw the invaders and the exploding invaders. So we're going to iterate through that invader structure, once again, which is 5 rows and 11 columns. if the invader at that row and column is active, we're going to get its X and Y. We're going to calculate its X and Y, and we're going to draw it. If instead they're exploding, we're going to kind of do the same thing. We're going to get the current frame number that they're on. Remember, there's 6 explosion graphics, 6 explosion frames. We're going to calculate the X and Y where that explosion should be, and then we're going to blit it to the screen. And then we're going to say, hey, and then we're going to increase the frame equals frame plus 1. But then we're going to say, hey, if the frame is equal to the length of the explosion graphics list, well, let's set exploding to false, because it's no longer exploding. It's gone through all of the explosion graphics. Then we're going to set the new frame and the new explode time. All right, we're going to loop through the present list, drawing it. We're going to draw the fireplaces. Now, this is where things do get a little bit complicated, because it's a little bit different. We can't just draw the fireplace, because once again, we want to erode the fireplace mask, and we've got a function for that when we go over to detect collisions. So what we're going to do, if the fireplace is active, we're going to create a mask surface, okay, by looking at the current fireplace mask. And we're going to do this. The unset color is 0, 0, 0, 0. What a mask does is it's essentially a bit mask with 1 bit corresponding to each pixel in the image. Any place there's a 0 in that bit mask, there should not be anything drawn. Any place where it's set, that pixel is set, or that bit mask is set, we're going to draw. So then we're going to create a filtered surface by using this pygame.surface, and we're going to pass to it the fireplace surface get size with this particular attribute, pygame.src alpha, or source alpha. Then we're going to say the filtered surface dot blit, and we're going to blit the fireplace image, okay, onto that filtered surface. This just creates a surface. This right here blits the fireplace image onto that surface. Then we're going to do fireplace surface dot blit mask surface, okay, 0, 0. So in the upper left and upper left. And so we're going to copy the original fireplace image, and then filtered surface dot blit mask surface. Special flags is pygame.blend RGB molt, and this is where we apply that mask to the filtered surface, and so none of the unset pixels will be drawn onto that filtered surface. Whew. And then finally we put it on the screen. This is the command, the function that actually draws it onto the screen. We're going to loop through our explosion list, drawing explosions, updating the frames, etc. This is pretty straightforward. This renders the text. And then finally, last thing we're going to do is, if game data show FPS, if that's set, we're going to draw the current frames per second that we're getting. All right, now let's go to the update function. So the update function is basically what it says. We're going to update the positions and states of a lot of the game objects in the game. First thing we're going to do is we're going to grab the current level. And so first off, we're going to see is Santa's sleigh active. Okay, if not game data, Santa's sleigh active. So if he is not active, we're going to check and see if he appears on the screen. And so we're going to take a look at pygame.time.getTicks minus game data sleigh time. In other words, we're going to see the last time he appeared. Has 11 seconds gone by? If 11 seconds have gone by, well, then we're going to check and see if he appears. And he has essentially about a 2% chance of appearing. And if he does, we're going to set him to active. I can get rid of that. I was having some issues, and so I was doing some debugging information. We don't need that. All right. And then we're going to set its X and Y and put them on the screen. else, that means he is on the screen. Because if he's not on the screen, well, then he is on the screen. And we're just going to update his X and Y, etc. Okay. And then we're going to check the bounds. Has he gone off the screen? If he has, we're going to set his active equal to false, and we're going to stop playing his sounds. Here, we're going to update the direction and position of the guided missile. So we're going to check once again, is it active? Because we don't want to do any of this if the bag isn't on the screen. And essentially the way this works here is we are going to get the distance in the X direction between the current bag's position and the player's position. And that's going to give us a number between negative whatever and positive whatever. And then we're going to calculate the speed. Essentially what's going to happen is the further away the bag is, the faster it's going to move towards you. So we're going to take that distance x, multiply it by 0.1, and then times the scale factor. And that's going to give us our speed in the x direction. You can speed it up or slow it down by changing this right here. We don't want them to go too fast, so we're going to set a max speed. And then this right here is where we finally set the speed of the bag. And what this does right here is it's going to limit the speed of the bag between negative max speed and max speed. So whatever this is, okay, it's going to limit the current speed of the bag in the x direction by negative max speed to positive max speed. Then we just set all the stuff for it, and we're going to say here we're going to check its bounds. Okay. We're going to check if it's off screen, and if so, we're going to deactivate it and stop its playing. We're going to spawn a guided bag if necessary. We're going to do kind of the same thing that we did up here with Santa. We're just going to check and see if it's active, and if it's not, we're going to see if the Santa sleigh is active, because we can't spawn a bag if Santa's not on the screen. And then basically we're going to do this. He has we're going to get a number between 0 and 5. And if it's less than 1, we're going to spawn a bag. Here we update the player star missile. All we're going to do is essentially, once again, increase it by its speed. We're going to increase its Y by star speed times scale factor. And then we're going to check if it's off the screen. We're going to do the same thing with update presence. We're going to update the explosions in the explosion list right here. Same thing, we're just going to loop. Now notice we iterate in reverse. So let me explain that. We're going to update the explosions in the explosion list. And if an explosion has reached the last frame, we're going to delete it from the list. It is really bad form to delete elements from a list while you are iterating over that list. However, if you do it in reverse, which is what this does, we're going to iterate over that list in reverse, you can get away with it. We're going to deactivate any fireplace that has a number of hits greater than 12. We're going to generate a random Santa shot. So we're going to get active invaders because we don't care. That's what this does. It's a list comprehension that's basically going to check our invader structure and only return active invaders, because an inactive invader frankly can't take a shot. And then we're going to say if we do have active invaders, and we have chosen a number that's greater than our invader shot chance, we're going to choose a random invader. And that invader is going to take a shot. Essentially, it's going to spawn a new present. Let's check invader movement limits. Basically, we want to know, we're going to assume that we're not going to reverse direction. That's what we're assuming. We are not going to reverse direction. And then we basically loop through the list once again for row in length invaders and for column in length invaders. And all we're going to do, and you know what I probably should have done, and I might change it before I upload it. I probably should have done the same thing up here, just got active invaders, because we don't care about inactive invaders. anyways, we're going to loop through it and basically check, are they on the far left? Is there any invader on the far left or any invader on the far right? And if so, we're going to set this reverse direction to true, and then we're going to break out of the loop. And then right here, we just say if reverse direction, in other words, if we're supposed to reverse direction, let's go ahead and we're going to multiply the invader's dir, the direction that traveling, by -1. And then we're going to move the invaders down, because remember, this right here keeps track of the upper left of the invaders array. So this is the Y coordinate. So we're going to move them down a little bit. 25 pixels times scale factor. We're going to move the X coordinate of the invader's position in the structure. Basically all we're going to do, and this is where we do that speed add. We're going to get the invader speed add. And then we're going to say the current speed is equal to level data current level invader speed. And so now we're going to increment the X position of that upper left corner of the invader structure by current speed plus speed add times the invader dir. Because remember, invader's dir is either going to be -1 or +1. And so if it's -1, we're going to essentially be subtracting from their X position times scale factor. And we're going to update our snowflakes. Here we're going to, once again, go in reverse, because we're going to check for any alien reaching the fireplace. And that's it for update. Okay, let's take a look at the detect collisions function and then the erode fireplaces function. And I think we're pretty much going to be done at that point. Most of the code is pretty self-explanatory. Detect collisions is a pretty long function, but it's pretty self-explanatory. First thing we're going to do is we're going to make a mask of the Santa's bag, because we're going to be doing mask-based collision with the Santa bag. First thing we're going to do, we're going to detect collisions between the guided missile bag and the player star. Pretty self-explanatory. Basically, if the bag is active and the star is active, that's the only time we're going to check for collisions for it. And basically, we're just going to use rectangle collision. We're going to say if the bag rectangle has collided with the star rectangle, we're going to play the Santa bag sound, or we're going to stop that sound. We're going to set the bag and the star to active. We're going to increase the player score. We're going to play the bang sound. We're going to make a rectangle based upon where the bag was, okay, and the width and height of the explosions. And we are going to swap the player image. So there's a variable called current player image, a global variable. And we have two player images, one with the star on top and one without. And essentially, when the star has been destroyed because it's hit a bag, the Santa's bag, or maybe a fireplace or an invader, we're going to swap it. We're going to say the current player image is equal to the player image with the star on top. And the current player mask, because we're going to do some mask-based collision detection later on, is equal to the mask with the player image star. We're going to make a new explosion and append it. We're going to do exactly the same thing with the guided missile and the bag and the player. It's pretty much exactly the same thing, except that we're going to use mask-based collision. Mask-based collision is pixel perfect collision. And we needed to do it with this because the player's image is kind of a triangle. And we want to be able to do pixel perfect collision with that. And so the mask-based collision requires an offset between the two objects that you're going to test. And so we calculate that as the Santa's bag X minus the player's position X, and the bag's rectangle Y minus the player rectangle Y. And then we just say, hey, if the current player mask overlaps with the bag mask, then we've got a collision, and we basically deactivate everything and set the game state to over. One thing, though, you probably might be asking, well, if mask collision is so good and it's pixel perfect, why don't we use it for everything? And it has to do with speed. Mask-based pixel perfect collision is a lot slower than simple rectangle-based collision. We could probably get away with it in this game doing mask-based collision for everything because there's not a lot going on. Then we're going to check collisions between the star and the invaders, and we're just going to, once again, we don't want to do it if the star is not active, and we just loop through each row and column, grabbing the invader at that spot, and then doing simple rectangle-based collision, and then this right here just sets the game data, etc., and creates a new explosion, or sets the invader to exploding, etc. We're only going to deal with active fireplaces, so we're going to do something similar where we only grab the active fireplaces with a simple little list comprehension here. And now we're going to detect collisions between the star and fireplaces. And this is where we're going to erode the fireplace. So we'll take a look at that function in just a minute. But the rest of it's pretty simple. We're going to do mask-based collision again. So we're going to calculate an offset between the star and the fireplace. And then we're going to use mass-based collision, and if they collide, we're going to do this right here. So we're going to grab the current player mask. We're going to swap the player image and player mask, and then what we're going to do is we're going to calculate the center. Okay, star rect center X, star rect center Y, and we're going to erode the fireplace based upon those coordinates. And erode fireplace takes a fireplace to erode, a set of coordinates where the erosion is going to be in world coordinates, and then a width that basically a radius that we want to erode. And I did explosion graphics.get width divided by 4. And here's the deal. If it was way too big if I didn't divide it by something, I'll show you. So you can see that's pretty large. That's crazy right there. All right. So you can play with it if you want. I liked dividing it by 4. It seemed to be pretty good. We're going to set the star active to false. We are going to get an X and a Y based upon where the star was. And once again, based upon the explosion graphics. We're going to play sound, and we're going to create a new explosion at that point, that X and Y point. And then we're going to append that to the explosion list and increase the number of hits on that fireplace. And so now let me go over erode fireplace, because most of the rest of this is the same. And so I'm not going to really go over most of the rest of detect collisions. So let's go over erode fireplace. This took me forever, y'all. I mean, literally forever to be able to erode the fireplaces, because this is something that I've never done before, ever. And so erode fireplaces takes a fireplace, the center, and that's a pair of coordinates, an X and a Y, okay? Essentially, that is the center of our circle that we're going to begin eroding, and then the radius of that circle. What we're going to do is we're going to convert the world coordinates, because this is the world coordinates, where on the screen the explosion has happened, and we're going to convert those world coordinates to fireplace coordinates, basically where on the fireplace did it actually occur, so we know where to erode the fireplace. And then all we're going to do is we're going to iterate, okay, through the mask pixels. That's the fireplace mask, okay? And what we're going to do is we're going to go from negative radius to radius plus 1 in both the X and the Y direction. And we're going to calculate, okay, at that spot, each spot, is that spot within the radius of the circle, okay? If it is, we are going to set mask X equal to the local center X plus X, okay? Basically, we're going to set the X and Y, okay, based upon the local coordinates of the fireplace. And then what we're going to do, what all this does right here, okay, it basically takes a look and says, okay, is there a spot within there for us to erode? Okay. In other words, this is hard to explain. We are going to set at each spot, okay, in the mask. We're going to turn that bit off if it's within the fireplace, it's within the radius that we have, and that pixel is already on. And so then we're going to turn it off. Because remember, in our drawing function, any place in the mask that's a 0, we are not going to draw it. All right. I think that, for the most part, is most of the game. The rest of it's pretty simple functions. Once again, if you have any questions, any comments, anything you want me to add, any way to do some stuff better, let me know down in the comments, and I will see you later. My next video is probably going to come out maybe in a few days. We're going to take a look at the Raspberry Pi 500, and we are going to attempt to stress test it. So, bye-bye. Hope you have a happy new year.